Hey, hello class. So in this video, we'll continue on section 5.4, and this here is very straightforward. The average value of a function, right? So if you want to find the average value of an integrable function, and again, integrable is the same as continuous, on the interval AB, well, it's just a definite integral, but you divide by the length of the interval. Because here, the length of the interval A to B is B minus A, so we're dividing by that, and that's it. Okay. Now, what does average value mean? Well, it means that it really, literally means that. So you look at your function, so you graph a function here, any function, say this on the interval AB, and you take the average out of all the function values. So all the function values, you add them all together and then divide by the length of the interval. That's the idea. Of course, there's infinitely many. That's why we need an integral. Now, it's not necessary for me to explain where this formula comes from. So this is what I'm going to do. I'll go over this video, and then I'll upload an extra video, right, which you're not going to be required to see. But if you're curious as to why, even though there's infinitely many numbers here, how this still works as an average, then you can look at the extra video I'm going to make. I'm probably going to call it, extra video 1 or something like that. So I'll go over that in an extra video. If you're curious about how this function, this expression actually gives you the average of the function and an interval, you can go ahead and look over it. If not, you can just memorize, okay, the average value of a function on an interval, okay, it's just a definite integral on that interval, and then I divide by the length of the interval. Okay. So you can do a really quick example. Find the average value of the function x squared plus 1 on the integral negative 2 to 2, on the interval negative 2 to 2. Okay. So by definition, the average value is going to be the integral from negative 2 to 2 of x squared plus 1 dx, with the extra thing that we divide by the length of the interval. So what's the length of the interval? And we did this when we were doing the Riemann sums. You just subtract the endpoints. So length is 4. It's as simple as that. Okay. So let's just go ahead and work it out real quick. So for now, you can forget about the 1/4. What's an antiderivative for x squared plus 1? Well, thankfully, we have a nice formula for this, right? You just add 1 to the exponent and divide by that new exponent. So an antiderivative would be x cubed divided by 3 plus x, right? And then remember the notation, evaluated from negative 2 to 2, sorry. Okay. So we simplify this. Again, we don't have to worry about the 1/4 until the end. So what does this mean? You plug in 2, so 2 cubed divided by 3 plus 2 minus, and now you plug in negative 2. So negative 2 cubed over 3, plug in negative 2 for x minus 2. Now let's simplify this. So 2 cubed is 8 divided by 3, so that's 8 cubes plus 2. Now, here we have minus negative 2 cubed, that's negative 8 divided by 3, so we get negative 8 cubes minus 2. Now let's distribute the minus sign. So we end up with 8/3 plus 2 minus minus, oops, I don't want to write, but we have minus negative 8/3, that's positive 8/3. Then we have minus 2, that's positive 2. Right, so now we combine everything. We have 8/3 plus 8/3, that's 16/3. 2 plus 2 is 4. Multiply the 1/4 out, and we get 4/3 plus 1. And again, it's as simple as that. Just take the definite integral, and you divide by the length of the integral. So that's it. Really nothing new here, other than, again, in the extra video, I'll explain where this formula comes from. For your purposes, if you're not really that interested in that, then just memorize how we did this. Okay, just definite integral, divide by the length of the integral. Now, one last thing, there's a sort of mean value theorem for the average value. And basically, it's the same. It's very similar to the mean value theorem we saw before. And so basically, it's just this statement. Let f be a continuous function on the interval a, b. And again, for us, continuous is the same as integrable. Then there exists a c in the open interval a, b, such that f of c equals the average value of the function. Right, that's it. So before f of c, before on the mean value theorem, we had f prime of c equals the slope of the secant line. Here we have f of c equals just the average value of the function. And that's it, right? So let's just use it in an example. Right? So use the mean value theorem for integrals on f of x equals e to the x on the interval 0, 2. So e to the x is continuous on the interval 0, 2. That's the only condition we need. So since e to the x is continuous or integrable, it's the same thing, on 0, 2, what does the mean value theorem tell us for mean value? It tells us that there exists a c in the open interval 0, 2 such that f of c, right, so e to the c equals the average value, right, of, so here the length of the interval is 2, right? You subtract the endpoints of the function. So basically, I didn't work this problem too well. What I'm trying to tell you is find c. So let's say we want to find c. Okay, so we simplify everything. So what's f of c? Well, that's e to the c. And here we still have this average value. So we need to simplify this. Okay, so e to the c equals, again, we don't have to worry about the 1/2 for now. What's an antiderivative of e to the x? Well, the derivative of e to the x is e to the x. So e to the x is an antiderivative for itself. So this becomes e to the x. Again, remember the notation, evaluated from 0 to 2. Simplify that. Again, we don't have to worry about the 1/2 until the end. This means plug in 2, subtract what you get when you plug in 0. E to the 0 is 1, so this becomes, after distributing everything, 1/2 times e to the 2 minus 1/2 times 1 is 1/2. So what do we get in the end? Minus. So in the end, what we're getting is that there exists a c such that e to the c equals 1/2 e to the 1/2 minus 1/2. 1/2 e to the 2 minus 1/2. And that's basically what you want to do in a problem like this. You first write this equation, which we can rewrite like this, and then you just simplify the right-hand side. And then you try to solve for c, right? Once you have it simplified. We want to solve for c, so what do we have to do? C is on the exponent, so we want to take the natural log of both sides. The natural log on the right-hand side cancels, right? ln and e cancel. So c equals the natural log of 1/2 e to the e squared minus 1/2. And this is the c that is guaranteed to exist by the mean value theorem. There exists a c such that the function value evaluated at c equals the average value of the function. And we found what that c is. And that's it. Okay. So this should get you through the homework for this section. Again, it's just even and odd functions, which is just a shortcut. And then the mean value theorem, which you can just memorize, definite integral, divide by the length of the interval. And then the mean value theorem, which basically just says that there is a c such that f of c equals the average value of the function. How do you solve a problem like that? Well, f of c equals the average value of the function, and then simplify both sides. Once you've done that, solve for c. Again, as I mentioned, I'm going to upload an extra video about how does the average value formula work, where does it come from. You don't have to watch it, it's going to be an extra video.